Greetings, dear colleagues. My name is Vitaly. I represent Volodymyr Dal East Ukrainian National University. Thank you for the opportunity to present our work today. So let's get started. Metamorphic changes in fossil coals proceeded mainly under the influence of temperature and pressures that developed in the Earth's crust as geological processes result. Most researchers recognize that of all the factors of metamorphism, temperature has the greatest influence. The change in an elemental composition of the initial organic matter is one of the main characteristics of the metamorphic process's manifestation. As the main indicator of metamorphic transformation of coal seams the release of volatile substances on dry ashless organic fuel mass during a coil thermal decomposition without air access is taken. This indicator and some others were borrowed without proper scientific justification from industrial classifications used in different periods. Metamorphic processes in natural conditions reached a certain stage of the original organic matter transformation at temperatures no more than 650 degrees. Thermal decompositions, according to the requirements, is carried out at 900 for 7 minutes. Thermal decomposition processes determine the coal's properties during their further transformations, which is important for establishing their consumer properties. Different temperature regimes in this case determine the formation of different products of thermal decomposition, the quantitative and qualitative composition of volatile substances. This proves that coal's metamorphism and their thermal decomposition are different forms of organic matter transformation, and the resulting chemical compounds differ significantly in qualitative and quantitative composition. Volatile matter wield is widely used to characterize the technological properties of coal. For these purposes, it is customary to determine volatile substances on a dry ashless mass. The existing method for determining volatile substances only approximately characterized the behavior of the coal organic mass during thermal destruction and is completely unacceptable at a high ash content of the sample. The above facts indicate that the volatile substances indicator was developed only to establish the consumer properties of coals, and it does not characterize the degree of seams transformation at different stages of their metamorphism. Its use to determine the hazardous properties of coal seams is not sufficiently scientifically substantiated. In this regard, there is need to improve the regulatory framework in terms of ensuring the safety of mining operations. Purpose and objectives of the study is to establish a set of basic indicators of the degree of metamorphic transformation of coal seams, which determine the manifestation of their dangerous properties during mining operations. Research methodology is developed based on the result of an analysis of currently known indicators of the degree metamorphism of coals and scientific justification for their possible use to characterize the hazardous properties of coal seams. Most indicators of fossil coals are designed to reliably establish the calorific value of coking capacity. For this purpose, at different times, the indicator of coking capacity, the yield of volatile matters, the carbon content in organic matter, the presence of analytical moisture, and brand identity were used. It is not possible to improve the regulatory framework for the safe mining of coal seams, in which the yield of volatile during the coal thermal decomposition volatile substances is used as the main indicator for several reasons. The main one is the thermal decomposition of coals in essence is a modern artificial stage in continuation of the coal transformation that occurred in earlier geological processes. The need to establish an indicative set of the degree of coal seams conversion is dictated by the lack of consensus of the use of individual indicators in solving engineering problems. In most cases, some indicator that is not directly related to the coil seams transformation is assigned an absolute role establishing the stage of metamorphism. Conventional coil grades established for their industrial use, according to the indicator, are taken as a criterion for general metamorphism in determining the dust generating capacity of coil seams. The danger of anthracite spontaneous combustion is made depend on the logarithm of the specific electrical resistance. In another case, the propensity of seams to spontaneous combustion was determined by the interrelated volatile substances and coil grades. Ultimately, coils of all grades from D to T were assigned to the group of increased endogenous hazard. Coil of the same grades from D to T fell into the category of coil seams where endogenous fires were absent. This once again indicates the absence of a direct connection between volatile substances and M indicators with the manifestation of hazardous properties of coil seams. The value of the volatile metals yield can differ significantly for different mines due to the heterogeneous petrographic composition of the organic mass. At all stages of improving industrial classification, the main criteria for the distribution of coils by consumer properties has been and remains to this day the yield of coal to organic matter. Subsequently, using the values of volatile substances, thickness of the plastic layer, and maximum moisture capacity, the coil was divided according to their technological qualities into 10 grades and 6 stages of metamorphism. The disparity between the grades and the number of stages is due to the fact that the transitional grades were determined simultaneously by 2 stages of metamorphism. In contrast to industrial classifications, determining the conformity of individual stages of metamorphic transformation of coil seam is a primary task for improving the regulatory framework for the safe conduct of mining operations. The division into 10 stages of metamorphism of formations according to the will of Koch has remained practically unchanged to date. This allows as the first approximations to compare the grades of coil with the corresponding stages of metamorphic transformation of coil seams. You can see that in table 1. The width of coke to organic matter uniquely determines the removal of fluids at each stage of formation transformation. The average value of coke corresponds to the amount of removed fluids based on the condition of their total 100% content in the dry ashless organic mass of the mine formation. In this case, in addition to gaseous products, the composition includes coal tar, pyrogenetic moisture, crude benzene, and other products of formations, metamorphic transformations. Significant changes are also observed in the elemental composition of organic matter. A linear inversely proportional decrease in the total organic matter components with an increase in carbon content indicates the predominant mechanical removal of fluids at the early and middle stages of lower metamorphism, and an insignificant amount of formation of new chemical compounds with the participation of carbon. A significant deviation of any organic matter component from its average values causes redistribution of their individual content in the elemental organic matter composition. This in turn determines the individual characteristics of the hazardous properties manifestation of coil seams during mining operations. If necessary, an additional analysis is made for anomalous composition of mineral impurities. A few final main conclusions are one of the main factors determining the manifestation of the hazardous properties of mines is the elemental composition of the original organic mass and the degree of its transformation during geological processes. The temperature of coal's thermal decomposition without air access when establishing their technological properties significantly exceed the temperature of metamorphic transformation of seams. This allows us to consider the products of thermal decomposition as the next stage of coal transformation, which is not related to the appearance of hazardous properties of coal seams. The basic principles of the methodology for predicting the hazardous properties of mines are proposed to be developed based on the deviation of the content of the organic mass matter main components, including moisture and sulfur from the average indicators. Other important conclusions can be found in the full version of the article. Thank you for your attention, colleagues. Have a good day.